Let's go, people. Illustrated Dictionary of Physics by USBONE. Na 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 na. Alright, firstly, we have to talk about the basics. Today, we're only going to be talking about mechanics and general physics and heat. So here we go, people. Here we go. Let's start off with a nice, fresh dose of atoms and molecules. Now, atoms and molecules are the basic individual components of life and literally everything. In fact, without atoms and molecules, nothing would exist. Just how would exist? My glossy hair wouldn't exist. My glasses wouldn't exist. My mom wouldn't exist. Also, thank you for existing. And they can be used to create lots of things. Molecules are just a compound of atoms, like a combination of atoms. Let me explain this further before I go into what molecules are. Atoms have different types in the world, and they're the indivisible building blocks. Also, we later found out that they are divisible. They're like three main parts of an atom, and those three main parts each have their own separate main parts, except for the electrons. So technically, two of the main parts of the atom have little quarks inside of them, which also have sort of like strings, and if string theory is correct, then, well, we're doomed. But the next thing I'm going to have to talk about is the fact that, well, atoms can combine together in chemical bonds, and there are different types of chemical bonds. Basically, if two atoms, which are the same type of atom, there are different types of atoms there, yes, are in a chemical bond together, two or more atoms that are the same type of atom, then basically this would become the molecule. And the next thing here is that if there are two different types of atoms that are chemically bonded, then that's a compound. Two or more different types of atoms that are connected together in a chemical way, that's a compound too. In fact, there are different types of atoms, and lots of people usually thought it was like this. And generally, nowadays, when we try to talk about molecules and atoms and molecules and compound physics, we basically look at them as general spheres, especially for when we're making models, because it's really hard to make atom models that are mostly empty space inside them stick together with little sticks, because then it's very fragile. Next thing is about the physical states. Now there's three: solids, liquids, and gases, and they look like this. The solids are very compact together. They vibrate, but not that much. Liquids are loosely connected together, so they can vibrate a bit much more. Gases aren't even connected to each other at all. Next fundamental thing I'm going to have to talk about is forces. Now, forces are awesome. They're the things that make things move. They're the things that make gravity become gravity. They're the things that make rockets fly up. It's gravity, the weak magnetic force, the strong magnetic force, the strong nuclear force, the weak nuclear force. So here are the four main forces of the whole universe: the strong nuclear force, the weak nuclear force, the electromagnetism, and the gravity. They're the four fundamental governing forces of nature and the universe itself. In fact, that's what magnetism is, basically just where a North Pole and a South Pole seem to work together to make magnets, and just magnets stick together. Also, they're usually in iron, nickel, and cobalt. And then energy is indivisible. It's unkillable. It's unkillable. Cannot destroy it. Cannot create it, so it'll be constant. The only problem with energy conservation, the only reason why people make us do energy conservation, is because every time we use energy, it turns a little bit of it or a lot of it into heat, which is why machines are hot, or why my phone is hot, or why sometimes phones explode, because they're used too much. And that heat gets trapped in the air. And nowadays, since we've also emit a lot of carbon dioxide, it gets trapped there. So the Earth is getting hotter, and if we stop using all this heat stuff and stop emitting carbon dioxide, then we would basically turn the whole planet into a healthy system again. We'll only need like 1 degree less of the global temperature just to fix it, because we're at 2 degrees of the global temperature right now. And 3 degrees is not as serious as 4 degrees. But to be honest, I think we'll just go to 3 degrees and start lowering down a little bit. Then we would try to get back to our normal days. And finally, we're at 1 degree. I wonder what I'm going to tell my kids when I say, back to my day. Like, what am I going to say? I wonder what I'm going to say. Now, next we have motion. Motion is like motions, and they're like moving. And motion is the change in position and orientation in object. Now the motion is based not like how you move and rigid object, or how rigid the object moves, and how it's made of translations or translational motions, as it's called. In fact, there's a thing called center of mass, which is where like center of gravity is, which is also the reason why empty pop bottles are easily to top over, and a little bit filled with water is a bottle a little bit of full of water. Pop bottle is very hard to push over to the empty pop bottle, and somehow a little bit of water inside a pop bottle is harder to push than a pop bottle that's full of water. Because the one that's empty and the one that's completely filled have the same center of mass, and the one that's a little bit filled, but not completely, that has a little lower mass, which makes it a bit harder to push over. It doesn't mean it's impossible though, it's just harder. And dynamics. Dynamics is a study between the relationship of the motion of an object and the forces that do it, that make that object move, like inertia, stream, loss of motion. All that is related to dynamics. And collisions are when two things smack into together, and opposites attract, and same things don't. They repel. And turning forces are just things that make things turn, which is what makes centrifugal forces move, and which is what makes these axles move. Also, we've never made a perpetual motion machine yet, because if it works, then the second law of thermodynamics should not be working. Now, next thing we have periodic motion, which is like motions that are like clocks, like that go ahead in periods of time, like moves there, after a few seconds move there, and then after the same amount of seconds move there, after the same amount of seconds move there, after the same amount of motion. So yeah, like that. That's a periodic motion, which is what makes pendulums work. And then we have gravitation. Gravitation is awesome here, because if Einstein said if the world was a stage and if the world was a play, the gravity would be the stage and the rest of the forces would be actors, mere actors. And which is why graviton should not exist, because if we make one particle for every force, that makes every force happen, and if we make one for gravity, the rest of the forces work with particles. But if we try to put that with gravity by putting in a graviton, our physics just messed up. They just messed themselves up. Next thing we're going to have to talk about is machines. Machines make things work, and they're the things that make work easier to do. In fact, they exert force themselves. We just need a little bit of force. We put a little force in the machine, and the machine will put a greater amount of force than we actually put in. It's not an energy creator, but it's an energy user. Why is this thing always tipping over? And then we even have molecular properties, like how they seem to expand and how they bounce around each other. In fact, I'm not even going to explain all this. I'm just doing a general idea of physics here. Density and pressure. And finally, we're at heat. We're talking about heat compressions and all those things. Now, we're going to have to talk about temperature. Wait, how many chapters are in heat? I feel like there are like almost none. Wow, there are almost none. And so temperature is a difference from heat. Heat is the energy that makes things hot. Temperature is the units that we use to measure how hot the object is. Heat is just the energy. Temperature is a measurement of that energy. Also, the definition of temperature might be confusing, and lots of people think it's interchangeable with heat and temperature. It is not. Now, there's three scales that nowadays people use. The Americans, for some reason, use Fahrenheit, a very complicated system that is not so divisible. Celsius, the ones I prefer to use, is very easy, is another temperature scale that most of the world actually uses because it's on a base 10 scale. Like 100 degrees Celsius is when water boils, 0 degrees Celsius is when ice freezes, and yeah, and 0 degrees Celsius is something amount of Fahrenheit degrees, so that's actually a bit of a mind bender to me. Kelvins are great mind benders, and these are the ones that physicists use, also not as much as Celsius, so 0 kelvins would basically be absolute zero, which would make atoms stop moving completely. It should be even colder than space. However, it's physically impossible to get to 0 kelvins, and if someone makes a 0 kelvins atom, then we would be doomed, because then people could just freeze us, and we'd be all like, hey, accidentally run to 0 kelvins and suddenly get paralyzed and dies almost instantly. Next, we would have to talk about the transfer of heat. Now, you need conductors to be transferring heat. Apparently, air is a good transfer of heat because heat just makes particles shake more, and the harder it shakes, the hotter it gets. Wood is a good conductor of heat, also not that much to be honest. Metals are a great conductor of heat, which is why metals are really cold when you touch them because they're absorbing your heat. Wood, however, isn't, which is why whenever you touch wood, it's not that cold. And lots of things are insulators and conductors of heat. And if you want to make a good thing, then you need conductors of heat or insulators of heat, because if you have conductors of heat, it will most likely melt if it's at too hot. And how heat transfers is also the biggest way you can make things. If you can't make heat transfer, then you can't melt stuff and forge them into other things, or you can't cook stuff. And we need to cook stuff because if we don't, it tastes bad and it's bad for it's worse for our bodies. And we even have to talk about expansion of heating, because if it gets hotter, the object always expands just a bit. How much we have no idea. It depends on the object. And if it gets colder, it contracts or shrinks, like Ant-Man, except on smaller proportions, or should I say bigger proportions? I'm not really sure how to say. And that's pretty much where we're at. I haven't even talked about pressure. I haven't even talked about pressure or waves yet, which waves are for next episode, but pressure, wow. So that's about it. I hope you guys enjoyed this episode of Hunter and Sean. I hope to see you guys soon. And so until then, Sean out, peace, and keep sciencing. Science rules. Da, 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 Bill Nye the Science Guy. That's a nice song. Bill Nye the Science Guy. Bill Nye the Science Guy.